Testing. Hello, welcome to the video. So here we're dealing with a data set. They don't tell us the context for this data, so it's just practicing with our kind of raw math skills here. But they've taken the data in this table and organized it into a stem and leaf plot, and right away we can see some advantages why you might want to do this with a data set in real life. If this were the data you were looking at and you had to pick out what's the biggest value here, you'd have to scan through every number and try to keep track in your head and try to remember, and you might say, oh, 28 looks pretty low, and then you'd find 25, and then 27. It would be hard work. Whereas if you organize it in a stem and leaf plot, you can very quickly look and see, oh, you know, here's the number of values in the between 25 and 29. Here's the number of values between 30 and 34. So that's the next thing I want to talk about as we interpret a stem and leaf plot. The stem is telling us the tens digit here, and the leaf is telling us the units digit. So if we look at this 2 with the 5 as a leaf, it's telling us there's one number 25 in this table. If we look at the 7 as a leaf, it tells us there's one number 27 in the table, etc. And it's a split stem and leaf plot, so the thing you need to keep in mind when you do a split stem and leaf plot that makes it different from a regular stem and leaf plot is that each stem has 2 leaves. One leaf for the lower half of values, one leaf for the upper half of values. So when we split up our stem and leaf plot, let's see if I can turn this into a pen. When we split our stem and leaf plot, it means the first one is going to have all values ending between 0 and 4, and the second stem will have all values ending between 5 and 9. So if we go here and have the last 2 to fill in, first we're going to take all the data values in the 40s. So let's go through and identify those. We've got a 45, a 43, a 41, 47, 42, and a 44 that we need to assign. And they're asking which should be entered in the last row of this table. So the last row of the table is all values in the 5s to the 9, so all values between 45 and 49. So we're going to have to enter that 45, 43, 41 would go in the first stem, 47 we'll need, 42 and 44 would go in the other stem. So for that last stem, it's going to be the 45 and the 47. We like to list them from smallest to biggest, so it would be a 5 and then a 7. So that's what WAMAP's looking for its answer there, the 5 and the 7. Just for completion and for practice, let's fill in these values too. For that other stem, we'd have 41, so that's going to be a 1, 42, which would be interpreted as a 2, then the 43, which we put as a leaf of a 3, and the 44, which we put as a leaf of a 4. If you had all these typed in the same font, the stem and leaf plot would be a very helpful way to quickly almost assess this information as if it were a histogram. To see which category had the most values, we could say, oh, you know, we're seeing a lot of values in the low 30s, not a lot of values in the high 40s. That kind of quick judgment could be made by organizing the information in this way. Just for completion, let's fill in our answer here. It would be 50. It looks like a 57, but really those are the leaves, a 5 and a 7.